Hi, today I'm going to have you take a look at some application problems. And our goals today, first of all, yes, we want to be able to solve a linear system, but we really want to be able to interpret the solution in the context of the real life situation. That's what's important today. It's being able to take a solution to a system and apply it to the problem. So when you're done with watching the video today, I'd like you to try the day 5 assignment posted in Schoology. There's just 3 problems that I'd like you to do. All right, so here is our first of 2 examples. Here we have the Theater Guild is printing programs for almost Maine. The expenses are 90 cents for printing and $600 for the setup fee and upgrade for the heavier paper. The price for each program is $1.50 per copy. How many copies of the program do they need to sell in order to break even? So in this situation, we're going to let X represent the number of copies, and we're going to let Y represent the total cost. So what we're going to do is we're going to write our 2 equations first. The first equation is related to the expenses. So the expenses are 90 cents for printing. So that's per copy of the print. And then $600 for the setup fee and the upgrade to the heavier paper. So to get a total cost, we would have to take 90 cents for every copy that's printed. So if there's 10 copies, it's 90 cents times 10. If there's 100 copies, it's 90 cents times 100, and so on. But in addition to that, there's the $600 setup fee. So that's all used to calculate the total cost that the Theater Guild has just to print the programs before they even have the play, Almost Maine. Next, I want to take a look at the profit. Okay, so that first equation is really just the expenses that they have. The profit is where they can sell each program. So their total cost or profit, I guess, is that it's $1.50 for every copy. Now there's not an additional cost to that. Basically, it's just when people come to watch, they pay an extra $1.50, $1.50 for each program that they want to have when they watch the show. So our job is to try to figure out how many copies of the program do they need to sell in order to break even, because they want to know if it makes sense. If they only expect 50 people to show up, will they break even selling 50 copies? Maybe, maybe not. But this is where we solve. So we're going to take this system of equations and we're going to use the solve by graphing method. So I need to minimize this so I can see the equations. There we go. Y equals 0.90x plus 600. There's our expense equation. And then our revenue equation. Y equals 1.50 times x. So we want to know, where do these 2 lines meet? Now I only see the blue line, so let's go ahead and zoom out. Zoom out. Oh my goodness, we're zooming out a long ways. Oh, now I'm starting to see the red line. Okay. Way up there. I want to know what the coordinates of that point are. So I click on a line. My gray dot appears. So it looks like the x value is 1,000 and the y value is 1,500. So my solution, 1,000, 1,500. So keep in mind what these numbers represent. If 1,000 is the x value, that's the total number of copies. 1,500 was the y value, that's the total cost. So at 1,000 copies, if I do 1,000 times 90 cents and then add the $600 setup fee, that would cost the Theater Guild $1,500 just to print the programs. But if they sell 1,000 copies and they get $1.50 for each copy, they'd actually make $1,500 in terms of revenue. So that's the point when the expenses are the exact same amount as the revenue. So to answer this question, we don't just say the ordered pair 1,000 comma 1,500. We look at how the question is worded. How many copies of the program do they need to sell in order to break even? 1,000 copies. And that's it. It didn't ask us for the amount. It just asked us for how many copies there were. All right, here we have our second problem. Ross and Rachel are going out for some coffees. At Central Perk Coffee Shop, 2 mochas and 3 cappuccinos cost $12.25. 5 mochas and 7 cappuccinos cost $29.50. We're going to use this information to find the cost of each mocha and the cost of each cappuccino. Our 2 variables are just that. X will be the cost of each mocha, Y will be the cost of a cappuccino. So the information we have, let's take a look at the sentences. All right, 2 mochas and 3 cappuccinos cost $12.25. Well, if I buy 2 mochas, to find the total cost, I'd have to take 2 times the cost of each mocha. So 2 times X. If I'm also buying 3 cappuccinos, I want to take 3 times the cost of a cappuccino. And based on this sentence, I know that buying 2 mochas and 3 cappuccinos would cost $12.25. Then we had another sentence that gave us some more information. 5 mochas and 7 cappuccinos cost $29.50. So we get our second equation. So that's our system of equations. Looks like we're probably going to want to use graphing as our fastest method of solving this. X plus 3y equals 12.25. And 5x plus 7y equals 29.50. All right, let's make it bigger so we can see the graph. Let's go back to the main zoom. All right, and kind of see what's happening here. Click on a line, and it looks like the 2 lines are intersecting right there. 2.75 and 2.25. And you might be thinking, wait a minute, how is it 2.75 mochas and 2.25 cappuccinos? But you have to remember, X and Y didn't represent the number of cappuccinos and mochas. It was the cost of each one. So 2 3/4, 2.75 was the value of X. And what was the other one? 2.25 was the value of Y. So just matching up our variables. Okay, X was the mochas. So each mocha would cost $2.75. And each cappuccino would cost $2.25. That's how we can use linear systems to help us solve the problem.